Good morning, ladies and gentlemen. Welcome to the Additive Manufacturing European Conference, AMEC 2022, organized by SESIMO, the European Association of the Machine Tool Industries and Related Manufacturing Technologies. SESIMO brings together 15 national associations of machine tool builders, which represent approximately 1,300 industrial enterprises in Europe, covering 98% of total machine tool production in Europe and about 34% worldwide. The AMEC conference has been running every year since 2015 to foster the interest of the EU community about additive manufacturing. It is the only conference at EU level where senior industrialists talk directly to members of the European Parliament and officials of the EU institutions about additive manufacturing, or AM. We'll refer to additive manufacturing as AM for short. We have a lot to discuss, so let's get started. First, I would like to quickly introduce myself. My name is Davide Scher. I am a journalist and market analyst. I am also the co-founder and CEO of 3D BPM, a leading global media and market research company that specializes exclusively on additive manufacturing, which we also refer to as industrial 3D printing sometimes. As 3D BPM, we publish 3D Printing Media Network, one of the leading news and editorial online portals trusted by additive manufacturing professionals all over the world. We also conduct extensive market research and publish reports on all the key applications of additive manufacturing, from aerospace, medical, and automotive to consumer products, bioprinting, constructions, and beyond. Today, we will hear from EU policymakers and representatives from various sectors of the European additive manufacturing landscape in two panels that will explore the most pressing issues relating to sustainability, entrepreneurship, long-term investments, supply chain resiliency, and viable applications of AM in the single European market. Before we start, let me just make a quick service announcement. The conference is going to be recorded and you will receive a link to access it. You are all welcome to ask questions that will be answered at the end of the panel sessions. Please write them in the chat or in the Q&A section. Our first panel speakers today will focus on policy. I'd like to introduce Dominique Riquet, member of the European Parliament and co-chair of the Sustainable and Long-Term Investment and Competitive European Industry Intergroup, and Thomas Heinemeyer, Directorate General for Internal Market, Industry, Entrepreneurship, and SMEs, DG GROW, European Commission. Mr. Riquet is a member of the European Parliament since 2009. He is a member of the Committee on Transport and Tourism, as well as of the Committee on Industry, Research, and Energy. He's also founder and co-chair of the Intergroup on Sustainable Long-Term Investments and Competitive European Industry. Mr. Riquet, please go ahead.
Thank you very much. Good morning, everybody. I would like to thank the European Association of the Machine Tool Industries for their invitation to speak today at this event dedicated to additive manufacturing, which I name AM for a more simple thing after. In most cases, EM is not a new standalone technology, but it will complement traditional forms of production in strategic sectors for the European economy, such as transport, aerospace, or medical. So far, European companies have developed a competitive advantage in the development of this manufacturing technique, but there are still many financial and technical hurdles. It is therefore essential to intensify European investments. What is at stake is competitiveness, resilience, and autonomy of our economy in general and of our supply chain in particular. As a member of the Industry Committee of the European Parliament, I follow very closely issues related to the functioning of supply chains. I welcome the fact that industrial stakeholders are increasingly mobilized to raise policymakers' awareness about how AM works and in which sectors it can be used. We need such technical input to feed our reflection on how to elaborate a tailor-made and supportive regulatory and financial framework to support the deployment of innovative manufacturing technologies in industrial process. It's a critical time for our European industry because it faces three challenges. At first, challenges is related to the pandemic, which showed how easily supply chain can be disrupted and exposed our vulnerabilities in several strategic sectors. Secondly, competition with the EU, with the US and Asian countries is stronger than ever. And thirdly, the industry, being very energy intensive, needs to play its part in the fight against climate change, what is likely to put pressure on the smooth functioning of the global supply chain. Deploying disruptive technologies able to address these challenges is essential. 3D printing as a new manufacturing technique could bring a valuable contribution to that by enabling mass customization and diversification of product and reducing the time from concept to production with higher eco-efficiency. It also represents the opportunity to promote a knowledge-intensive European industry based on a high quality and skilled workforce, which will require investments in upskilling and reskilling of the existing workforce. Depending on the sectors, 3D printing has been there for quite some time, and we see a rapid evolution of this technique with multiple growth opportunities. In the health sector in particular, it offers the opportunity to change the manufacturing of medical products, particularly high-risk devices for patients such as implants, but costs still remain high compared to conventional technology. It has also potential application in the manufacturing of pharmaceutical by enabling unique dosage forms and formulation. However, it raises questions about the regulatory overview of device and pharmaceutical production by this technique, for which we still have little experience at this stage. In the aviation sector, companies are already experimenting benefits from 3D printing, which offer a unique opportunity to bring down aircraft production costs while minimizing material scrap and production times. 3D printed parts are also lighter than their traditionally manufactured counterparts. Airbus is one of the companies leading the way in additive manufacturing, with several EM parts flying on its aircraft, majority made from polymer and more from metal. We can see the company installing 3D printing bionic spacer on a series of a 320 aircraft and experimenting with 3D printing on more complex components, such as engine parts. However, EM faces some key challenges related to size and scalability limitation, a narrow range of materials, mainly polymers, and high material costs, which lower the incentive to use EM in production. In the automotive sector, 3D printing also could provide benefit in terms of lightweight design and production flexibility, but costs, speed, and production volumes are currently far from being competitive compared to traditional manufacturing. Overall, despite being at an early stage of development in most sectors, we can already see that additive manufacturing provides an unprecedented level of supply chain flexibility, which is more than necessary in current and troubled times for the industry. Indeed, the crisis impacting supply chain, but subcontracting companies in a very vulnerable situation. Big companies originating orders are at the forefront when facing crisis and are the ones to decide on crisis management. But the most exposed and probably the less resilient to unpredictable changes in supply chain management are precisely the subcontracting companies. Additive manufacturing provides for a stronger adaptation capacity while lowering production costs and material scrap. I call for the EU to increase its financial support by creating a specific funding instrument aimed at consolidating the resilience of industrial supply chains. The entire supply chain could benefit from it. So thank you for your attention, and I'm looking forward to hearing Mr. Heinemeyer, directing of DG Grow. Thank you very much for your attention.
Thank you very much for that. It's really fascinating to hear that the EU is aware of all the issues ongoing in the industry. You mentioned funding. How do you think the EU can support innovative industries such as 3D printing in deploying their solutions in the single market? Funding I'm sure is a big part of that, but even beyond that.
Yeah, this is provided by the EU. The uptake of the 3D printing is first and foremost financial too, but also regulatory, I think, as you see. Concerning the financial dimension, the support could be provided by various existing EU funds and programs, such as InvestEU, Horizon Europe, with all its stall and also partnerships, EIB, Member State National Promotional Bank, and institution, and so on. So far, we saw that Horizon 2020 and the Joint Plan has been useful tools to fund the development of EM in different sectors. As I said earlier, I believe that a specific fund, something which was specific, dedicated to support in the natural supply chain exclusively, should be created. And I call on the Commission to consider the added value of such a fund. But public funds will not be enough, as you see, and the contribution of private investor will also be essential. Concerning the other part for the regulatory dimension, which I think is also very important, it must be flexible enough to allow for significant innovation progresses while ensuring a strong scrutiny on standardization. IP rights and product liability, especially in sensitive sector such as health and transport too. Our main concern should be to give businesses the freedom needed to innovate without adding unnecessary constraint and avoiding to be too much prescriptive. I think that a space of liberty and some flexibility will be probably very useful for the company to go forwards.
Thank you very much for that. Thank you for your talk. Our next, we will go on to our next speaker now is Mr. Heinemeyer. I would like to ask Mr. Heinemeyer to turn on your camera and microphone. Thank you. And Mr. Heinemeyer is a mechanical engineer who has been working on innovation for more than 20 years. He started with foresight studies in innovation at the European Commission's Joint Research Center, worked on digitalization of industrial processes, and later on innovation and industrial policy in the European Commission. Mr. Heinemeyer, please go ahead.
Thank you. So, yes, industrial policy has a different connotation depending on persons and organizations. So I think that there has been quite an evolution in industrial policy over the last decades. The OECD several years back has actually been seen to write of a new generation of industrial policy that has come about, which is, according to the OECD, characterized essentially by a strong emphasis on innovation and a stronger emphasis than before on the regulatory framework, to the detriment of the, how shall I say, more classical or traditional understanding of industrial policy as targeting specific industries or even enterprises. Indeed, when one looks at the EU industrial policy, one sees a certain continuity over the last decades where innovation has started, research and innovation has been very strong, and the digitalization and environmental aspects have then gained in strength throughout what we call the communications by the Commission on Industrial Policy. The one of 2020, indeed, is a strong reaction to the so-called Green Deal, where the aspects of the green transition and the digital transition have become very strong. They indeed dominate a bit the considerations at present. Nevertheless, the focus of the EU industrial policy, the main objective, which is and stays the competitiveness. Now, in the industrial policy, throughout its different communications and commissions and communications, the items on green and digital have always been present. What has changed a bit in the last decade is that the investment part has become much more prominent, together with an emphasis on investment environment that has to be favorable, so that instruments like already Mr. Riquet has mentioned, InvestEU in the future, can actually have their expected effect. And more recently, in the communication of this year, the internal market, or the single market, has risen in visibility of its importance. Indeed, the EU industrial policy is done even without the communications, as one former industry commissioner once said. It takes essentially place in other policy areas. So in the 21, oh, excuse me, there a German has stayed in. So the update of the industrial policy in 2021 is a reaction to the experience we made with under COVID-19 situation. It does not at least substitute what has been done in previous communications. It rather adds on it in terms of strengthening the single market resilience, to analyze and address the strategic dependencies, and to accelerate the twin green and digital transitions. In this, central is a concept of industrial ecosystem, to which I will come back later. The first lesson, indeed, the resilience of the single market. There, I want to indicate only one new instrument that will be proposed, which will go apparently under the name Single Market Emergency Instrument. There, the mechanisms shall be proposed to improve the reaction in case of disruption to supply chains. Other measures like single market surveillance and other aspects will also come, but for the supply chains, that is essentially the instrument. And the dependencies, they are also currently in the media related to certain shortages that industry experiences. Here, one works with the industry and also with our international partners to see what can be done to actually diversify the imports or increase certain stocks. But the point here is also that the information on where our dependencies are and what could be done about it shall be improved. Here, the most advanced at present is the one on raw materials, which was also presented then as a document accompanying the communication on the industrial policy update. But we are not only dependent, we have also strong areas. But in some very important areas, we have also seen confirmation actually that we miss some strategic capacity. So here we have reinforced instruments like industrial alliances, but also this acronym of IPK in R&D, which stands for important projects of common European interest in research and development, which actually can go quite far into industrial deployment, where companies large and small from several member states find together and have a huge program to undertake. This is actually something which is coming from the member states, so question of state aids come in here, but therefore these IPCEI have a special guidance. In this regard, but not only, we will also pay particular attention to SME participation, especially, but not only, that also some startups can take part in these. For the third lesson, the acceleration, there something called the transition pathways shall be elaborated to define what shall actually be done, what is needed in the industrial ecosystems to get the twin transitions actually done. I will come back to that later. All this, we are very aware that it can only be done together with industry, on one side the industrial alliances, but also to define what needs to be done, the industry forum. And here we have one, in the context of the industry forum, we have one task force on advanced manufacturing, where the additive manufacturing topic is actually very prominent. Sessimo is actually one of the co-responsible organizations, and we are glad that they take over this function and works well together with us in this context. Mr. Riquet has already mentioned it. The regulatory framework has to be set well for what is needed for the transitions. On one side, that one actually knows how the innovations have to be specified, what one has to do, but then also for the diffusion across the economy. Now, data and EU-wide data spaces sounds like digital. It is, but it has also a specific relevance for advanced manufacturing, and therefore also for the additive manufacturing, because there are currently considerations to make a European, well, a EU-wide data space specifically for their industry. With regards to skills, there we continue to promote so-called competence pacts. That is a sort of agreement between stakeholders active, having an interest in developing certain skills, be it curricular, be practical activities across member states, indeed. And then on the financial side, obviously, the Horizon Europe Research Framework Program. And here, additive manufacturing, many of you will know it, are part of the so-called key enabling technologies, which have a prominent role in the thematic areas of Horizon Europe. Indeed, there will be a specific call on actually two calls for additive manufacturing in the future. And one specific item that is not only but also of interest to SMEs are the cooperation networks, where the lowest blue one is the interesting for your area. That is actually part, so that is the European Digital Innovation Hub network. And these are part of Digital Europe program. Now, looking at the time, I just want to point out that there are organizations that are active in this area and that could become could constitute this network for your specific area. The call for expression of interest is open until the 22nd of February. I will pass on the address where you can find the information on the web to Sessimo after the event. Now, industrial ecosystem, what does this mean? Well, it has two components. One is a so-called partnership principle, which essentially says the ecosystem brings all together that have an interest, that are active in a certain industrial area. And these areas, they are put together with a view on, how shall I say, policy objectives. The conventionally known sectors were grouped together according to the needs for investment following the situation after COVID, but also in view of the transition. Most of these areas have been grouped a bit together. There are some core areas, so I have put some examples here. They are not the only ones in these ecosystems. And then there is one type of industry which is in which actually yours falls, which is an industry that we call in this context a horizontal industry. What has happened with these is that you do not find them as such in one or two ecosystems only. They were split according to the value added on the side of their using industries, their customer industries, to the other industries, and therefore have always a certain share in the ecosystems. So for yours, so the machinery and equipment, the sector where the machine tools belong to, they are spread over several industries. The most prominent are mobility and construction, and then they are followed by actually agri-food and aerospace, which has been mentioned by Mr. Riquet already. Now, transition pathways will be defined per industrial ecosystem. As actionable plans, they will have to deal with certain milestones that have to be done over the future, the regulatory conditions, investment needs, but also how they can finance, then the skill needs and possibilities, but also international aspects like what we do with our partners to on regulatory cooperation to get also a reduction in difficulties to get into other geographic markets, but also the demand stimulation with regard to the diffusion and others. Now these pathways, we cannot define them ourselves. Here we depend and we rely on industry. The basis here is that one needs a bottom-up understanding of what researchers and industry needs. The Industrial Forum is one such instrument that I have already mentioned, but there are also, depending on the ecosystems and the policy mechanisms that the colleagues have, certain expert groups, but then scenarios on possible pathways will be subject to public consultations. Two are already out. One may be of interest, especially on the material side for you, which is the energy-intensive industrial ecosystem. Then these consultations, the responses to the consultations will be taken up, the pathways will be further elaborated and then validated again with industry. Now, this means for horizontal industries like yours that you actually have to follow several consultations, that you may contribute quite specifically to where you see regulatory conditions, investment skills needs, international needs in the corresponding international industrial ecosystem, excuse me. And with this, I hope that I can get now my screen off. No, apparently like this. Okay, so.
Thank you very much for that presentation. That connects, the policy to the industry. And now we're going on to our industry panel, and Mr. Heinemeier will also join us in the panel discussion afterwards. So on to our industry panel presentations. I would like to I'm going to introduce you to speakers who come from some of the most dynamic and interesting segments of AM, including AM production services, software, constructions, which we've heard about, and personalized medical implants. But first, I would like to introduce Stuart Lane, who is here as chairman of the Sessimo Additive Manufacturing Committee. Stuart is a non-executive director of the is also non-executive director of the UK's Manufacturing Technology Association. And since 2018, he has been chairman of the Additive Manufacturing Committee at Sessimo. He is also currently the sales director of Renisha's French subsidiary based in Paris. So Stuart, please go ahead with your keynote.
Thank you, David. And before I start, I just want to say thank you for your support on this initiative today. It's nice to see you again. Thank you for the floor, and thank you to everybody else for their participation today. I've just got a few slides to show you before we get on to the really interesting subject, which is, of course, the panelists. So I won't take too much of your time. Briefly, for those of you who are not familiar with Sessimo, we are an umbrella organisation that served since 1950 the common interests of machine tool industries and related manufacturing technologies, and that's both at a EU and indeed global level. Sessimo promotes our industries in Brussels, and we are experts in the field of economy, technology and innovation for those sectors. And our members consist of 15 national associations who themselves doing a fantastic job of promoting AM and its best practice use in their specific countries. So we're very much a collaborative approach across Europe. The association's goal is to promote the AM sector, raise awareness to policymakers and other relevant stakeholders, hence the conference today. We offer a platform for the AM community to discuss elements of their business, and in particular those subjects important to them, market growth, and indeed barriers to growth, be they regulatory or non-regulatory. We also talk funding from R&D through to production of parts. We support efforts on standardization and certification, which are incredibly important for our industry to grow and mature. And also, of course, a subject very close to my own heart, the skills shortage. Today, I just want to give you a brief overview of some of the most relevant Sessimo activities on AM and the opportunities that we see for this sector. So first of all, it's worth mentioning that Sessimo launched a market survey in cooperation with national associations, Italy, Switzerland, Austria, Spain, and the UK. And this survey aims to collect and disseminate quality data straight from the industry and help companies understand the trends and drivers in the AM market. It's something that we've been doing for the machine tool industry for a long time, and we're very proud to be offering a similar service for the AM community. This survey is taken directly from 3D printing companies that are operating in participating countries. It's a survey that is issued every 6 months, and you can see the key data and indicators that we present on the screen. Due to its comprehensive structure, the survey helps shed light on the European AM business cycle and the overall industry situation with respect to production, demand, investment, and other elements of the market. For your information, the latest edition of this market report was published last week and is available on the Sessimo website, www.sessimo.eu. Before going into policy initiatives that we advocate, it's important to highlight that the EU is the most innovative of regions within the AM market. According to the latest report from the European Patent Office, Europe accounted for 47% of all AM innovations for which a patent application was filed between 2010-2018, with major activities coming from Germany, Spain, Netherlands, and Belgium. If we're to give you a comparison with respect to other regions, the US over the same period of time accounted for 35% of those patent applications, Japan 9, South Korea 1, and China less than 1. It is our belief that this trend will grow and further improve thanks to the investment and supportive policies that the EU and many national governments within Europe are putting in place. The European Union, for example, has launched a bold strategy to become the front runner of the green and digital transition. And of course, we believe that the AM sector has a lot to offer in supporting those policies. Today, I just want to highlight 2 initiatives that, in our opinion, will be of the most benefit to the AM sector that the European Union can support us on. The first one is the European Union Industrial Strategy Policy, which was launched in 2020 and updated 21. With this strategy, the European policymakers have decided to strengthen the industrial ecosystems, foster development and adoption of key enabling technologies, such as AM, and in particular, the strategy looks at, amongst other things, how we can increase supply chain resilience, enable localized or on-demand manufacturing, and reduce, to an extent, international dependencies. And I repeat, AM has an awful lot to offer in that space. Sessimo has promoted additive manufacturing on various occasions, highlighting, for instance, that on-demand manufacturing will find wider resonance as companies across the world try to de-risk their operations and indeed their supply chains. The second initiative is the circular economy. The action plan also launched in 2020. Such a plan includes several policy initiatives that will bring the EU closer to increasing its overall sustainability objectives. Although many of the circular economy action plan initiatives focus on a limited market segment, shall we say, they provide an opportunity, and I think we heard about these horizontal classifications earlier. They provide an opportunity for governments and business to look at technologies that enable sustainability. Therefore, as you can see from this slide, we believe the AM sector is well placed to support and achieve many of these circular economies objectives. If we move on to slide 8, it's worth mentioning that AM is also part of international trade policy, and in particular with the newly established Trade and Technology Council with the US, a platform that will serve as a forum for the United States and the European Union to coordinate approaches on different issues, such as global trade, economic development, and innovative technologies. And both the US and EU delegations have chosen additive manufacturing among areas of cooperation, which is great news, we think. As the US remains a key commercial partner for the European machine tool industry, Sessimo will be an active member of this new platform, and we will provide critical input on harmonized standards, export controls, and indeed global trade challenges. Finally, we must all recognize that there will be no digital and green transition without a skilled workforce. Therefore, industry and policymakers have an unprecedented opportunity to finance and develop specific measures to prepare the workforce for the many changes brought by this new digital and sustainable transition. The lack of available skills in additive manufacturing remains one of the largest challenges for our sector's potential. To mention one example, the quick adoption of AM solutions in hospital will immediately demand a newly specialized workforce. Therefore, it is essential to expand the pool of European workers who can work with the whole process of design through to final part processing and manufacture in various industrial sectors. Many current initiatives and projects aim to tackle the skills shortage by answering the industry's demand for personnel rather than planning how to develop the needed competencies among workers. At Sessimo, we're part of an exciting European project called SAM, and let me give you a brief details of this project, as we believe it's bringing real value added to our community. The project was launched in 2019 and tackles the current European need to develop an effective system to identify and anticipate the right skills and talent for additive manufacturing. This project is developing a European observatory in AM that will identify and anticipate the right skills and deliver them to industry through a solid network of European training centers. In addition, the project launched a series of activities, including free online courses for the AM workforce. One of the most relevant efforts this year was the launch of its European roadmap for additive manufacturing to tackle skills gaps across the 3D printing sector. The strategy outlines the critical skills shortage related challenges currently facing the 3D printing industry, referred to by SAM as gap drivers, and proposes several strategic objectives and initiatives to address these obstacles. I wanted to conclude my presentation with a crucial point. The AM industry's natural business ecosystem has encouraged companies to work together. But to unleash the potential of this sector, industry players should increase the level of collaboration to improve the technology, identify new applications, and enable users to exploit its advantages to the full. Such an ecosystem should include multiple partners from the whole AM value chain working together with one goal: develop new products and services that can boost the entire sector's growth in the manufacturing industry. In addition, it should be able to scale up quickly, include new partners as the market expands, be resilient, and quickly adapt to changing regulations, technological advancement, and of course, customer needs. At Sessimo, we will continue to provide a platform to discuss and promote and create a thriving AM ecosystem in Europe. And with that, I would like to conclude my speech and thank you all for your time.
Thank you very much for that, Mr. Lane. Let's go on to our next speaker, who is Crystal Vandenberg, Director of Innovation at Materialize. For those who are not immediately familiar with Materialize, Materialize is one of the most, if not the most important additive manufacturing service provider and a pioneer and leader in additive manufacturing specific software. Crystal oversees the innovation consultancy branch of Materialize, a world leader in 3D printing services. Her team of consultants and technical experts assist companies in unlocking business value via the adoption of additive, whether they are just getting started or already in the process of scaling up their 3D printing activities. Crystal, please go ahead with your presentation.
Hello, thank you. Thank you very much, Davide. Let me share my screen, see if that works. All right. So hello, everyone. My name is Crystal. I'm Director of Innovation at Materialize, one of the pioneering companies in the additive manufacturing space. And today I want to talk about how additive can ignite transformative innovation. Now, to start off with, we're living really complex and challenging times. And I think the COVID crisis has affected all of us professionally, personally, and obviously it has had a huge impact on manufacturing industries as well. Supply chains broke down, productions were halted, and so that caused a lot of problems. Now, we have also seen that additive actually was a bit of a lifesaver in this entire context. There were a lot of broken supply chains where on-demand production was helping, but also additive enabled new acute need for products, which I will come back to later. So this only strengthened, let's say, the growing reputation of additive manufacturing as a real tool for resilience, but also as a valid tool for production, end part production, both in aerospace. It has gained its mark as well in very certified environments like medical implant sector. Now, this is good news because additive is really moving high up on the agenda of business leaders, not just business leaders, also policymakers. And that's great. In fact, 90% today of leaders want to adopt additive manufacturing as a manufacturing technology. The bad news is that today, 80% of the manufacturers are still working mainly on rapid prototyping. So how do we explain this gap? Well, because rapid prototyping, which is really enabling fast product development, is a whole new paradigm compared to certified additive manufacturing. In prototyping, it's all about speed, but these prototypes don't need to meet end requirements. So they mainly serve as illustrative purposes or to speed up the development. Whereas when you're really talking about parts that go into airplanes or parts that go into bodies, obviously there you need to meet a whole spectrum of requirements. You need to also ensure the quality, reliability, and consistency. So this is a huge challenge. And to get from point A to point B, it is quite a complex journey. In fact, Materialize, it has been mentioned, we have been in this space for more than 30 years. So the first thing we actually built is the 3 core capabilities that you need to überhaupt be able to produce. And so we are a leader in the software for additive. We have one of the most complete additive manufacturing plants in the world with a very broad range of materials and different printing technologies. And we have the largest pool of engineers, software engineers, clinical engineers, and medical and design engineers. Now you could say, wow, that's already a great achievement and we're enabling a lot of companies, but this was never the end goal of our company. The end goal really was enabling new and meaningful applications of 3D printing. And that's something we've also done in parallel. So here on the left, you can see our vertical applications. We are producing our own medical implants in Leuven, in our ISO 13485 production facility. We have a whole production line now set up for eyewear frames. We are in the business of tooling for automotive, and there's other production lines that are not standing here. And so when I speak about applications, it's really about going from an idea, a vision of revolutionizing healthcare, which we started 20 years ago, to now today going up to a fully certified and automated production line specifically for that application. And going through this journey really gave us some important lessons. And the first lesson is that additive manufacturing does not start with buying hardware. It's not plug and play. It doesn't happen overnight. Now you could say, Crystal, that's a very obvious thing you're saying, but that's really not true because I've seen so many hospitals, companies who are sitting on very expensive equipment, which is just collecting dust because they have not thought about what the applications are, what the needs are, what the product requirements are, and have invested, and they get stuck in a sunk cost fallacy. So that's a lesson we've learned. And a second lesson we've learned, so what is then the right answer, is that additive manufacturing truly is a complex journey. And there's really distinct stages and phases you have to go through. And obviously, once you have your application, your business case, there you want to scale up your production and invest in the right equipment. But many companies skip a lot of these steps. Now, to be successful at this journey, at navigating it, there's actually two things I believe are really, really crucial. The first one is you need an impetus for change. You need to have an important, urgent reason and relevant reason. You don't want to 3D print for the sake of 3D printing, for investing in this journey. And if you don't have that catalyst, or the business case is not valid enough, you will probably not get through it. That's the first point. The second point is you need guidance and expertise, access to knowledge, experience, and capability. So I was very glad to hear that is something also the EU will invest in making this available, because it is really crucial. And to not keep it too theoretical, I just want to run through some cases to show you how we, with Materialize and my team, the Minder consultancy team, try to enable companies who are in very different stages of the journey, who have different drivers. I listed some of them here, and also have different challenges related to where they are in their journey. So let me get started with the first case study of CNH. It's a global agricultural manufacturing company. And CNH was already really working with additive for several years. They had a dream, and the dream was to digitize their inventory. I think this has been said many times, because you can order spares without delay or overstock. You can engage in distributed manufacturing. What were they doing then for several years? They started mainly with rapid prototyping. They had one full-time equivalent working on Industry 4.0. But in reality, despite of these efforts, it was a very slow progress, because there was not an urgency. As I mentioned, you need a catalyst. And obviously that catalyst came with the COVID crisis. They really risked their supply chain to break down, because a key component for this assembly line, which was produced in China, went missing. And this was obviously a big wake-up call. So what happened is CNH reached out to Materialize for this component, a chain tightener. And as you can see, it's not a part who has a lot of design complexity, because that's not the point here. Here, the point is, can you produce on demand urgently these components so that we can plug it into our assembly line and avoid a standstill? So that's where there was no file available either. So we had to reverse engineer the component, produce it, and ship it to CNH, and Additive basically saved the day. But this was obviously a big wake-up call. And so after that, CNH realized, okay, we're spending a lot of effort on 3D printing, but it's not coordinated. We don't have a global strategy. And so the next step in our collaboration was really setting that corporate additive strategy, looking at the corporate goals, the context they were operating in from a business, translating that in additive business goals with a lot of focus areas. One focus area was aftermarket. Another focus area was, how can we include additive already in the design of new tractors and new end parts. And here you see one complete fast track that we had on the spare parts, where we really helped them find and screen new additive applications, prioritize them, because it's not because a spare part has a big business need that it is good for additive manufacturing. And that's where our experts really help them. And of course, redesign and engineer for printability, for enhanced functionality. And this is a program then that we have set up with them. And we're proud to say that 1.5 years later, CNH estimates around 50% of their global production facilities are now really working on additive, not just for prototyping, but also for end parts. So conclusion, additive catalyst was here a broken supply chain, risk mitigation. The driver is on-demand distributed manufacturing, accessibility to small series. The scope is both end parts, but also production process parts, like a part of an assembly line. And the challenge was the strategy, the screening and selection of applications, and the design engineering for parts. The second study, case study is for Hyundai Automotive. Hyundai Automotive has the largest manufacturing plant based in Korea, in Ulsan to be precise. And we were actually invited by the government of Korea because, just like in Europe, the goal is to really enhance skills and adoption of additive manufacturing. So I find that a very interesting approach, and I think it would be great if we can do a similar type of co-creation project in Europe. So what we do here is that this plant in Ulsan, they produce around 50 new car models globally a year. And here you can see the production line, where line workers have to inspect the body of the car to make sure there's no gap and flush errors. this is both done in a mass production stage before the car leaves the plant, but also in the pre-production stage, because if there's any design errors, you want to know that before you launch this new model into mass production. Reversing that would be very, very expensive. Now, to do that, these workers use inspection tools. Those are jigs and fixtures, they handheld tools. And this is an example of the traditionally manufactured jig in aluminium. And there were quite some issues with these jigs. First of all, the lead time. These components, it took three months when a new car model was designed. You get these finished goods, it took 3 months. It was too slow. Because if you got the pre-production running and you don't have the jigs yet, there was a risk that these cars would go into mass manufacturing with errors. So that's the first problem. Secondly, the accuracy of the jig was 0.15 millimeter. Ideally, if you want to also work at mass production standards, you want to bring that down to an accuracy of 0.1 millimeter. And then the weight. This is very important because it was weighing 1.8 kilograms. Workers had to lift the device 100 times at the speed of once per minute. So you can imagine this was also for the health and safety of the workers not ideal. So the next step to say, okay, how can you use additive to reinvent and improve those jigs was to think, okay, how should we adapt the design? Which kind of technology and material should we use? And is there any finishing needed? Now, this seems like a quite simple question, but a lot of companies struggle here because they think like for like. If it was aluminium, of course, we will go for aluminium. We've seen that a lot in the manufacturing sector, that this traditional way of thinking is keeping them fixed. Now, I have to also admit it's not an easy question because today the battery of materials and technologies with additive is growing so vast, also the finishing options, that it's a bit like a maze and companies need to get through it efficiently. And that's really where we come in with the experts to help them make the right choices based on the application. Now, in this case specifically, we moved on to a selective laser sintering component. We used polyamide filled with aluminium, so we call that alumide. And because we had these particles inside, we were still able to mill the part and reach a very high accuracy. If you also look at design, it's a lightweight structure, but still strong thanks to the honeycomb design. And finally, of course, it was milled and painted as a finish. Now, this component really was a two-in-one solution. It was accurate enough to use in pre-production and in mass production. It had the same accuracy, but it was 50% lighter, which is very important for the workers. There was no assembly because we could do integrated functionality of the locators. And most importantly as well, the desired lead time, we were able to bring that down to 1 month and prevent design errors going to mass production. Now, this was a quite successful project. I think we've done it in a one month and a half, from spotting a need in that entire plant to delivering such a solution. But if you think about the fact that today at Hyundai, they produce 50 new car models globally, but every car model requires on average dozens of different inspection jigs only for the lamp assemblies, and they have so many new models, you can imagine that these kind of solutions, and they're really mass custom production tools for Hyundai and will have a major impact on their global operations. To conclude, the catalyst here is both costs for avoiding recalls, risk mitigation on branding and reputation of wrong cars in the market, and the health and safety of workers. The driver is the customization of tooling, the lightweight design, the fast lead times. The scope here is not the end product. We did not work on the car, but we worked on jigs and fixtures, so on the process. And the challenge was to find the right material and technology design options, redesign and produce a working prototype in a short lead time. My final case study is about the medtech industry, and it's an example from Materialize ourselves, because as you know, we are really also a medical device company. And here it's interesting because when COVID hit us, the first thing that was done in Materialize was setting up 3 task forces to create new products that were acutely needed in the market. We had 3 teams, one working on the critical medical devices, one on the protective equipment that you can see here, and finally on the prevention devices, you could say gadgets to help avoid spreading the virus. For example, our hands-free door opener, which was developed in a week's time, received more than 100,000 downloads, which is a nice example of once you have a file, you can put it in the cloud and distributed manufacturing can happen locally. But what I want to talk about today is this passive PEEP mask, because that was really an excellent achievement of what our company was able to realize. At a certain time, there were many patients in the hospitals, but there were not enough ventilators to cope with this crisis, and people were literally dying because of that. So what happened is that we had pulmonologists reaching out and saying, okay, we need to develop quickly a new solution together with the engineering team of Materialize. I put our CEO here feed because he was the one to say, okay, there is an acute need in the market. We need to act fast. And in 2 weeks' time, we were able to develop this PEEP mask, which basically was giving positive pressure on the lungs, which was avoiding the fluid of the lungs to get up again. And hence these people having this mask did not need a ventilator anymore. And why am I putting this here? Because it really proves that with additive, you can go in 2 weeks' time from a drawing on the whiteboard, obviously discussed with experts from both sides, to having first prototypes and to having finally a fully certified product available to save lives. We went from idea to concept in 8 days, and then there's another 2 weeks that was fast-tracked by the regulatory authorities to have a clearance for this. And this is really important because if it was not for this collaboration with the authorities, this device would not have been made available. Also, we made the file available to different hospitals who had printing capacities, so it could be manufactured locally. And obviously, this result was also only possible because for 20 years now, we have been producing medical devices. So we have in-house capabilities on engineering and production. So here the catalyst was acute need in the market due to the lack of ventilators. The driver here is fast end product development, small series. The scope was really an end part. It was a medical device, a PEEP mask. And the challenge was to really engage in rapid product development, but also really use the current and tailor the current production capacity to this device. Now, I showed you a couple of examples. I don't have a lot of time. It's only 10 minutes. And there are other stories that I could have shown you. I mainly focused on the first 2 stages. In the enable phase here, it's more about companies that who need to scale up their production. And so they're really struggling with automation of their process flow, certification and qualification. But this was just to give you a flavor. And what I would like you to really remember is that we all now know that we want to get to additive manufacturing, but the reality is a lot of companies are stuck in prototyping. And the answer is going through the journey with the right experts, with the right companies of capabilities, also with the regulatory authorities and the government. And the only thing way to do is finding right catalysts for change, the real reason why you want to engage in additive, and also really partner up, team up to get access to knowledge, experience, and capabilities in additive manufacturing. That was my presentation, and if you have any questions, obviously I will be happy to answer them later in the panel, or you can get in touch with me later. Thank you very much.
Thank you very much, Crystal, for that presentation and for showing us some of the applications that can help to drive the transition. Very practical applications, actually, which is refreshing. But also we can look a little bit more into the future with our next speaker is Francesca Moretti, who is co-founder and creative director at WASP. For those who are not familiar with the company, WASP was one of the very first innovators and pioneers in the concept of construction 3D printing, which is something that has been gaining some very rapid adoption in recent years and months. And it is certainly one of the most dynamic and fascinating areas of AM. Incidentally, WASP is also one of the first and most important manufacturers of entry-level and now also industrial 3D printers in Italy. Francesca is a co-founder of WASP. Since 2012, she has been dealing with business development and communications with the company. And in 2021, she became the company's CEO. Passionate about digital communication and design, she is a WASP brand ambassador and plays a significant role in the challenges of the WASP research and discovery team. Francesca, please go ahead with your presentation.
Hello, everyone. Thank you for your time and for having me here. David, it's correctly, do you see correctly the presentation?
I actually see you started screen sharing, but I don't see the presentation at this time. It says you started screen sharing. I'm not sure if I'm the only one not seeing it. Let me just check.
Still see.
Maybe we can try to reshare. Try stop sharing and reshare the screen. Okay, because we were seeing it before, so it should work. In case, I think we can also run the slides for you. No, it says for some reason, oh wait, something's happening. No, I still see a black screen. So maybe I can ask.
Yes, I can share it for you, Francesca.
Okay, thank you.
Let's go with that. This is the beauty of live events. Thank you.
Okay.
Just please indicate when you want to go to the next slide.
Okay, I will write directly in the chat, so that way I will not interrupt my phrase. It's okay. 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 Thanks a lot for having me here. I'm Francesca. I started this project around 9 years ago in Italy. And we can go to the next. Okay. We approached about 3D printing not only in terms of technical project and development of machine because we are producer, but because maybe thanks also for our design background, we thought about the needs and the application of the additive manufacturing in general. And our guide phrase we have is in the next exactly. So we are not so crazy to think we can save the world, but we are crazy enough to work for it. So this phrase follow all our work because our aim was to have a big changement in the rules of the game in general, and we thought that 3D printing can help us in this direction. So the meaning of that for us was we cannot stop because we are not perfect in our project, but we need to keep on research and go in the direction of the changement. And the pottery wasp is is for sure what we thought was the best business model for us and the model of development for our project, because these insects take from the place the material they need. She needs for make a tiny house, a small house, and also the water was taken from the place around, and all the energy these insects have is put in the direction of construct something that is really functional and useful without any waste. So we took the pottery wasp as the business model of wasp, and we go to have the insects in our logo. Our approach till the beginning was to be frugal and active in all the direction that for us was correct for develop the company. So the vision of WASP was the big aim we have to construct big houses in with the local soil. And I'm here in the sector of project where we made the project, we developed machines, and next to us we have the product where we produce machines, and selling the machines we put energy and money in the project side, and we go in the direction of our vision. The basic needs we found was food, house, have energy, work, and art and culture, and we thought that 3D printing was a good way to make application in all these fields. And yes, today we will talk about the houses and what we do in this research that we found ourselves. We have here some example houses I think is the most disruptive WASP have, but also health application, energy with a recycled plastic. We printed directly with our printers, work with a technical thermoplastic we print, and food and vertical application about food, and hard with ceramic, because we start with small printers that we scaled up till the big one we have for clay and earth. But we have also this application with a ceramic and 3D printing. The proof of concept we have had at first was Gaia, next to our headquarters. As you can see here, you have this wall. It's totally 3D printed with local soil. Here, the settings of the on-site building, where we have this frame. This machine is a called a crane wasp. It's basically a kind of crane or arm that you can easily move around the world in a container. And also the design of it was made for be easily moved and managed with 3 people, 4 people in a day, and start printing directly using the soil we have on the place we go to print. Why? Because we thought, as the pottery wasp do, that using less energy as possible to create material and printing directly with material without any sort of chemical addition inside is the best way to give an answer to the needs that we will have in the future of many houses. And this is for us the best options, and for sure it's really not easy to achieve, but as in the next, you can see here Tekla. Around 2 years ago, we go on the research, and we have here something that don't need the roof, because we are thinking that we can also print in a place where wood is not easy to achieve. And this is a really challenging project, a research project. I thought Gaia is more easy to replicate around the world instead of Tekla, but we want to push to the limit the technology and our research to better understand the possibility for the future, and also not only in the future, but what we can do now for the needs of human and the needs of our planet in terms of environment and eco-sustainability. We have here the first, I think the first case study in the world where you can see 2 arms that work together simultaneously to print directly and on site the material we have. Also the same here in the corner, in the left hand corner, you see the material we took directly on site. About the material, there's a lot of things to tell and to introduce to you, because it's not so easy as I'm explaining now to take directly earth and print something that can be using for people. It's a really big terms of research for us, and we are open also a research about geopolymers that we can use instead of cement and regular concrete. Okay, we can go to the next one. Okay, here the same Tekla on the top, just to show you. It's really big. It was a really big object for us. and I think the first one, dome, made by 3D printing. So in terms of design and shapes, it was not easy. This project was made in collaboration with the architect Mario Cucinella and his studios. Here an internal view. And this one is a house of dust that we made with a pre-mixed material. And the design of this material was the same of the one we had here. It was sand, raw earth like clay and straw, and husk of rice, because this material was provided by Rice House in Italy. So also the next steps for us, in order to make possible our project, is to create a premix material that we can easily achieve reproducing it around the world with the local soil and local raw fiber or raw fiber in general, as the insects do. So work around the place we will go to print, and take material we can have locally. Here during the printing, the object was smaller, but the technology is the same. And here, in the last proof of concept we have had in Dubai, this is a concept store with the Maison Dior. They accept the challenging project, and we easily bring the machine directly in Dubai, and for printing the same natural material mixture, the same natural material mix design we have had also in Italy. And it was the first time for us for having something that can be used for shops, for something that can be in the real life, as can I say. We can go next. Here a night view where we have really clear the work we have done on the surface in terms of code. We put this pattern on the surface, so we were like a technical tailor, because every layer means a possible error in terms of design, but I can say the shapes and the final result was good. Here a daily view, and also the next one, the interior, where we can see all the object setted, and that gives us the possibility to say that this technology can be put in the real life, and also natural materials can be also chic, and not only for a small part of sensible people in the world. Here during the printing with the team of WASP. And here the building site. Also next, all the application of WASP in terms of food, energy, but I think our time is done. So as you prefer, we can go really quick. Here the application and the blender we have done with
Fantastic.
yeah,
the Burning Man.
This is the Burning Man. This one is a scan of me also, where these artists put directly and print the part of the opera. And the next one is an interaction between the artists and the 3D printers that print clay. And here are our resellers around the world, and next one, the WASP Hub, that usually we work together for print big object like the Burning Man one. And that's it. Thank you.
Thank you very much for that really inspiring presentation. It's truly amazing what you have been able to achieve with the construction technology, and we're seeing so much innovation in that segment. So it's really going to be interesting to see what will come. Our next speaker is Michele Presaco, who is Vice President of Research and Development at Lima Corporate since 2014. Lima, for those who are not familiar with the company, was one of the very first companies to develop and manufacture implants using additive manufacturing, actual additive manufacturing factories, and it is one of the largest manufacturers of titanium additively manufactured orthopedic implants today. As I was saying, Michele is Vice President of Research and Development at Lima Corporate since 2014. Previously, he has covered different roles within the product development division, where he has contributed with over 20 patents and the launch of several successful products. He is member of the management team and the IP board within Lima Corporate. So Michele, please go ahead with your presentation.
Good morning, everybody. Thank you, Davide, for the introduction. I will start sharing my screen. Can you see the screen? Okay. So, good morning. My name is Michele Presaco. I'm the Vice President of Research and Development of Lima Corporate, and it's my pleasure to introduce you to our Trabecular Titanium technology and our journey in additive manufacturing. Before doing that, a couple of words about Lima Corporate. Lima is an Italian-based global medical device manufacturer providing reconstructive and custom-made solutions to orthopedic surgeons who are facing the challenges of improving the life of their patient. We believe that restoring the movement can be one of the greatest joys in a person's life. This is why in everything we do, we are passionately driven by our desire to restore the emotion of motion. We do that thanks to a pioneer vision to deliver innovation and drive digital transformation of orthopedics. The patient is at the center of what we do as we continuously collaborate with surgeons to improve the clinical outcomes. We are recognized for the Italian design, deep expertise in engineering, as well as in advanced manufacturing. Lima is for sure considered a leader and a pioneer in 3D printing, being one of the first company, if not the first company in the world, in taking this technology from rapid prototyping into mass production of medical devices. When we invented Trabecular Titanium, the aim was to improve the bone ingrowth and as a consequence, the long-term follow-up, clinical follow-up of the products over the conventional coating. Trabecular titanium is a complex 3D structure which is made by a cellular base cell, which is known as the diamond structure, because it's exactly the same structure that we found in nature in the diamonds, which is repeated to fill the space and is made by means of additive manufacturing. And in particular, we use electron beam melting to create the material, which is also made by means of titanium alloy. The Delta TT product, the first product we have applied this technology, has almost 15 years of clinical heritage. Has been approved by all the regulatory authorities. We started 2007 with the CE mark, but then has been approved by the FDA, TGA, PMDA, and over 150,000 products has been implanted worldwide. There are several studies and publications that shows the superior performances, clinical performances of this 3D printed product compared to the others that are actually on the market. Recently, we have received a rating, which is the ODEP 10A, which is the highest rating, the highest valuation in terms of survivorship at 10 years follow-up. Over the years, we have applied the technology to other products behind the hip, like the shoulder, the elbow, and more recently, the knee. No other company in our segment, in our sector, has such a wide range of application. This picture represents an Italian alpinist, Romano Benetta. Together with his wife, they have climbed all the 14 highest peaks in the world without the support of oxygen mask. Already by itself, this is an outstanding achievement. But what it makes it even more amazing is that it did the last two peaks with a bilateral total hip replacement made of 3D printed beta TT cap. Of course, the choice of the implant was made intentionally by the surgeon because of the ingrow potential, because of the superior clinical performances, which can, in the end, as in this case, improve the man in patients' lives. As I said, we started with the Delta TT, which was conceived to be a primary cap. But of course, because of the high bone ingrow potential of the material, the natural evolution of the technology was the application into the revision, where we have designed a complete set of products in order to address most clinical cases, from the simple one to the more challenging one, where the cap is often combined with the cranial augments, which can you see in the picture, to fill bone defects. After the hip, we deployed the technology to the shoulder with the SMR Axioma, the first 3D printed product, 3D printed component applied to total shoulder replacement in the market, designed to address severe bone losses in the glenoid, and what we call the SMR stemless with a 3D printed core, which is used for both anatomic and reverse application in the shoulders. For the ones who are not expert in orthopedic, the anatomic configuration, which is the one on the left, replicates basically the anatomy that we have in nature, where the head is on the glenoid side and articulates on a concave surface on the scapula, called also the glenoid. While on the reverse, on the right, the articulation is reverted, so the glenosphere is mounted in the scapula and articulates on a socket on the humeral side. So having the same core, which is compatible with both, give the surgeon the ability to follow the evolution of the patient, and in case it develops a cap tear arthropathy and the shoulder has to be converted from anatomic into reverse to increase stability, they can do that without having the need to remove a fixed component. And this, in the end, translates into a less invasive procedure for the patient. Finally, we have completed the shoulder application with what we call the hybrid glenoid. Moving from the shoulder to the elbow, more recently has been, we started the control release of the TIMA elbow, which is the first and the only 3D printed total elbow in the market, which brings also other innovation beyond the 3D printing element. And finally, more recently, we have approached the knee with what we call the anatomical metaphysical fixation cones and the TT tibial plate. The cones are designed to address complex surgeries to create a sort of reinforcement of the bone to then host and create the support for the knee implant. This is the first product that we have done, which is finished only by means of 3D printing, which means that it does not require additional CNC machining. And of course, this is beneficial with the aim to reduce the cost of goods, which is still a barrier in terms of the development of the 3D printing technology. With the physical tibial plate, we have leveraged not only the capabilities of 3D printing to create lattices for bone ingrowth, but also the design has been topological optimized with the aim to minimize the micromotion, which is fundamental in order to have bone ingrowth, but also to optimize the distribution of the stresses from the implant to the bone, and also to maximize the fatigue strength of the component. The experience that we have been, the knowledge that we have developed in mastering 3D printing for over 15 years has been finally deployed to ProMade, our custom-made divisions that leverages the reliability of a process that has been developed for the mass production of off-the-shelf product to create a bespoke solution for patients with the most challenging clinical cases. The tailor implants can be also combined with our standard components in order to provide the intraoperative flexibility for the surgeons. The process to create a custom-made implant starts from the imaging. The ProMade team received the CT scan of the patient through a web portal. And from the CT scan, they reconstruct the anatomy of the patient. And on this anatomy, they design the implant that fits the needs of that specific patient according to the indication that we received working in strict collaboration with the orthopedic surgeon. And then the implant is finally manufactured by means of 3D printing and delivered to the hospital in sterile condition within 4 to 6 weeks lead time. What I've presented so far is the first pillar, the hardware of our strategy to deliver innovative hardware that leverages 3D printing for standard of the shelf as well as for custom-made products. But with the aim to transform orthopedics, we are adding other two elements, new innovative delivery strategies to provide implants and instruments to the hospital, and the software or the digital element with what we call the smart space ecosystem. In terms of new delivery strategy, in March 2021, we celebrated the grand opening of the first in the world point of care to design and 3D print custom-made solutions inside the hospital. And this was done at the Hospital for Special Surgery in New York, Manhattan. This is breaking the ground with the aim to foster and increase the speed and the accessibility of custom-made products for patients with very challenging and desperate clinical condition. Also, the proximity of the engineers with the surgeon will facilitate the interaction, will speed up the interaction, and hopefully will also improve the innovation for future developments. With the digital elements, we are giving the surgeons the ability to plan the surgery in 3D. The difference is, in this case, is the reconstruction of the anatomy of the patient, thanks to artificial intelligence, is made just in time within the laptop of the surgeon. So the surgeon don't have to send the imaging to the engineers and wait for them to reconstruct the anatomy, but he can do it just in time within few minutes in his laptop. And then once he has defined the plan, he can then execute the plan through what we call sensor-based guidance. Also, I'm telling this because also in this case, 3D printing plays a fundamental role because the patient-specific instrumentation that we use to map the anatomy for the guidance or to guide the surgical act, they are also made with 3D printing, and in this case with selective laser sintering. So in Lima, we started with the metal 3D printing, but in the last year, I would say that also the polymeric part has grown significantly. Bringing my section to a close, today I've shown you how Lima has over 15 years of experience in 3D printing with several off-the-shelf products developed, the ability to leverage this knowledge to create custom-made components for the most challenging cases. We set the ground to decentralize 3D printing from the historical production inside the company, and we have taken this into the hospital, inside the hospitals, and on top of all these elements, a digital solution to combine with. And I thank you for your attention.
Thank you. Thank you very much for that, Michele. And after seeing this, there is really no doubt in my mind that AM will play a key role, is playing a key role in the present of implant production, and more so in the future of implant production and many other applications. So we went a little bit long with the presentation, but it was definitely worth it. We will go through a shorter panel discussion, so I just kindly ask you all to keep the answers a little bit shorter. We will now move on to this Q&A session, and I have a few questions, and we will also try to take a few questions from the audience. But if we don't get to all of them, please feel free to reach out to Sessimo or to myself or to the panelists, and we will try to get your answers. So first, I would like to go back to Mr. Heinemeyer, who I believe is, I hope is still with us after all the presentations, to ask you, how will the European Commission coordinate its work with the member states to ensure that industry strategy helps to strengthen the EU market and make the supply chain more resilient?
Now, the member states are actually also present in the industrial forum that I mentioned, which is a very important instrument or place to actually define and see what can be done, what needs to be done along the transition pathways to make them realistic. So here we get in the industry forum direct, if I may say, tripartite feedback or dialogue actually between the industry representatives, the member states, and then the EU legislators with the proposals by the Commission. So that is essentially the important forum. And then obviously public bodies can, of all administrative level, can also take part in the public consultations. And then at the later stage, the validation. So here, possibilities and needs expressed by member states will also be taken on board, actually together with industry in an exchange then.
Thank you very much for that. And we received for our next question, we received a very interesting question from the audience. So I'll prioritize that. It's towards Materialize, about the Materialize presentation, which also the participant is also complimenting for the presentation, but he's asking that he would be interested to see how about the IP patent issues raised by having designs available for all to see, and how can this be best addressed in the future business environments. So I'll turn the question to you, Crystal.
Yes. Well, of course, IP is a very important topic, and it's especially true if you look at digital manufacturing, the distributed manufacturing. Before, we were in a centralized model where the OEM was producing the components, was controlling them, was responsible for it, was making physical stock. In a distributed world tomorrow, of course, how will that function? And to be honest, it's not that today there is already a clear answer. I think we need to also build the right legal frameworks and regulations around it, especially. So that is a very, very important point. Obviously, if you're looking at a company who's producing, let's say, for spare parts, investing a lot of time of R&D to coming up with designs, it's very obvious that in some way this research and development should be protected. But that does not mean that there might be new business models and new ways of still making that available. And so I think it's a valid point, and I don't think today we have an answer on the shelf to solve all of these issues. Now, for Materialize in particular, in this acute need, a company made the choice to say, we are saving lives here. For us, the priority now is not IP, but is to ensure that those devices are getting in the right hands at the hospitals and are saving lives. So that's really sometimes, an internal discussion and a choice that has to be made. But thank you for raising the question, because I was thinking what would be one point I would like to raise today is to really help policymakers also craft this right environment to take that into account and ensure it will not block these evolutions with additive manufacturing.
Thank you very much. And going back to Mr. Lane, we have a question about if you can give a little bit more information about what you're doing, what Sessimo is doing to help bridge the skills gap in the AIM sector, and please expand on the SAM project that you mentioned.
Thanks. I'll try and keep it brief due to the time, but we've been working on a four-pronged attack, if you like. So we've been working to try and get a more favourable policy framework within the EU. Of course, we've been asking for increased funding as well. I guess that comes as no surprise. We've been working on developing and implementing some EU dedicated projects like the SAM project that you just referred to, and also working on countrywide initiatives at national level, not just at EU level. Without going into the details of the SAM project too much, what I'd recommend is if you go to the Sessimo website, if you Google what SAM's about, Sessimo have been instrumental in that, as also the dissemination of AM training materials, which we think is extremely important, free of charge materials to get people up to speed. So what I'd recommend is people take the time, if they're interested, have a look on our website, Google what we've been up to. I'm sure you'll find it very interesting.
Thank you very much. And I have another question about to Michele about what are the main obstacles that you encounter in scaling to volume production in the healthcare sector, and also connected to that, how has the regulatory landscape in Europe been improving over the past 15 years? I mean, is this has it been visibly improving?
So yeah, I will start with the first part of the questions. So the challenges that we have to face along this year has been
sorry, I think we've lost you, Michele. I don't know if it's okay. Yes. So sorry. While Michele connects back again, we can move on to we have a question for Francesca on the latest applications of AM. So the latest applications that you've shown us have and the ones we've seen have shown really great potential. What do you think is needed before we can see a more widespread adoption of this technology across cities in Europe? Yes, this is actually the question.
Yeah.
And I have a follow-up, but I'll start with
you. I think the main themes now is the culture about the machines, how to properly use it and handle it. So create people that can print, not the owner and the makers of the machine have to be able to use the machine. So we are now creating the instrument to make it easy to use also for other people. And also I think in our case, mostly because of the not traditional material, also the bureaucratic and yes, I think bureaucratic and more legal aspect that we don't face properly because we are a producer of machines. So we need help in this direction for give the possibility to multiplicate the possibility to have houses in natural material 3D printed also.
Thank you very much. And my follow-up is was with respect to the Dubai Expo project, which is really fascinating. How you put the texture on the building, which is something probably totally unique as like many other applications. But do you think these kinds of projects can help you drive adoption of sustainable technologies in the construction industry?
I think yes. That's why I said the collaboration. I thought that such a strong message will be difficult to be pronounced differently because of the level of the collaboration we have had with the Maison. I think also the karma, the collective karma we have about concrete could be changed by giving really height and strong messages that have to fly above all of us, and then the actual result have to come after this kind of proof of concept. So yes, for sure, I think the inspiration remain of one of the most best suggestion for direct people in other way to construct and think also. So I think yes, it was a great way to show that is possible.
Thank you very much. And we have one more question from the audience, which if they're still with us, it's both from a policy point of view, from an EU point of view, and from an industry association point of view. So the question is, what core research and development or other actions should be addressed in future EU Horizon funding? I don't know if you want to quickly address this, Mr. Heinemeier or Mr. Lane.
I can, sorry.
So please go ahead, Mr. Heinemeier, then we'll pass it to Mr. Lane.
From my side, that depends essentially on where the researchers, where the industry, the enterprises see the next steps either in short term or then in needs milestones for the longer term. So there we are rather on the receiving end. I'm glad to hear the answer.
Thank you.
Okay, well, I'll answer a fairly short answer. I think anything that will ultimately drive the sale of parts, pulling through the sale of machinery. Now, as you probably guessed, I am in sales. What we need is those industries that are already in the process of adopting AIM technology to scale that up. And I think, therefore, that anything that can take the technology further in, for example, the aerospace and automotive sector, because they are some of the largest potential users. I know that there's already a lot of funding gone into those industries. I almost wonder whether funding of efforts to facilitate and speed up the approval of components for aerospace use would be money well spent, because those industries have been looking at these applications for some time now, and we really need to see the research converting into product that is flying or driving.
And thank you very much for clarifying all that up. And really, we went a little bit long, but this brings us to the end of this year's AMEC. Thank you very much to all our panelists for your time and great presentations and insights into some of the most interesting applications of additive manufacturing. We have seen how policy set in place and translate, can be set in place and translated into to meet industry demands. We have seen many the applications and needs that are driving this transition towards a more sustainable, economically and environmentally additive manufacturing, serial, and eventually mass production. Thank you again to all for participating virtually. Please feel free to reach out if you still have questions or would like more information on this event. Sessimo hopes to see you all again next year, hopefully back at the European Parliament with the in-person format as in all previous events. Until then, thank you again for joining today, and goodbye to everyone.